of BioZeroc, and very simply put, we use biotechnology to make hard things carbon negative. And I'll spend the next 5 to 7 minutes explain a bit more in depth what that means. When we were in the process of incorporating BioZeroc, a video went viral on the market. And we actually thought that brought quite good context to what it is that we're trying to do. So I'm going to show you a short clip of this video here today.
Well, I work with timber, which is a much more sustainable material rather than concrete. I also
But you work with trees that have been cut down then, don't you?
It's a sustainable building practice.
How is it sustainable if you're killing trees?
Because it's regenerative, you can grow trees.
Right. Well, you can grow all sorts of things, can't you?
Well, you can't grow concrete.
You can. See you coming. Cheerio.
Yeah, and as much I hate to say it, the arrogant guy in the clip is actually right. You can grow concrete, and that is the core of what we're doing at BioZeroc. So, taking it back to the basics, what is concrete? Concrete is a mineral-based composite material that is used quite literally everywhere around us. The term concrete jungle is real. It's in houses, hospitals, factories, bridges, roads, pavings, dams, sustainable foundations for wind farms. It's everywhere. So perhaps it isn't a surprise that concrete is the most used material after water on this planet. It's altogether responsible for 8% of our global carbon emissions. And putting that in perspective, that's 4 times more than the whole aviation industry. So why is concrete so bad? To make concrete, you mix sand, aggregate, water, admixtures, and cement. It's quite a common misconception that concrete and cement is the same thing. It is not. Concrete is the final material that you apply, and cement is the chemical glue that holds everything else together. So while sand and aggregate accounts for about 85% of the mixture of concrete, it is the cement that accounts for about 90% of the carbon footprint. So if this needs emphasizing in a room full of climate-conscious people, that's really bad. So can't we just use a bit less of it? Well, there are a lot of companies looking at reducing the amount of cement we use. And that is genuinely fantastic, because we need all the solutions we can get if we're going to have a chance at reaching our climate targets. But it's just not good enough. We need radical change that are entirely free from cement if we're going to have a chance at combating climate change. So at BioZeroc, we asked a quite simple question. How does nature do it? Nature has already figured out how to make strong, durable, carbon-negative materials that last for centuries and doesn't cost the Earth. And making materials inspired by nature's own processes brings so much more potential. Biomimicry is the concept of designing materials or systems based on biological processes. And by doing this in materials, we have the potential of making them smarter, stronger, and regenerative, just like trees. So at BioZeroc, we use natural processes, mix bacteria with circular waste to grow rocks. Doing this in between the sand and aggregates means that we are organically cementing them together with a carbon-negative process. So yes, we do grow concrete. And the best part, this organic binder is cost competitive to cement. But Some might think, isn't it a bit scary if we release bacteria all across our cities? Well, bad news for you, it's already done. Self-healing concrete was rolled out about 20 years ago, which is when you mix bacteria to ordinary concrete to make it more durable by letting the bacteria heal cracks. This makes ordinary concrete longer lasting and better performing. The barrier we have overcome is scaling this throughout the element to not only add a bit to concrete, but build the fundamental structures. So bacteria is no longer an additive, it's the fundamental binder. And by growing rocks, making concrete is really just the beginning. Premium materials like stone and marble come at really high emissions due to the mining, cutting, grinding, polishing, transportation, and processing that are associated with them. Since we are effectively growing rocks, we can replace these premium materials with something that's grown directly into its final shape, locally on site. So we are BioZeroc, and we are here to revolutionize the construction industry with biotechnology. If you want to follow what we do, sign up to our newsletter or come speak to me after. Thanks.